Good afternoon, everyone. Welcome to my lecture. I am N. Kranti Kumar, working as assistant professor in Saint Martin Engineering College in Department of CSAML. Today, I give my lecture on deadlocks in operating system. Here, what is mean by operating system? Operating system is nothing but a interface between the user and hardware resources. Here, the hardware resources are nothing but hardware resources. We have CPU. Hardware resources are CPU and memory and input output devices. Input output devices means we have CPU and memory and input output devices like CPU, keyboard, mouse, CPU, keyboard, mouse and printer, scanner, and these are all comes under the input output devices, and these are the system resources. The operating system provides the interface between the user and the hardware resources. These are the resources. And next, deadlock. What is meant by deadlock? Deadlock is nothing but it is a situation when two or more processes executing at that time, one process holding the resource and another process also holding the resource, and the first process is request the another resource that is occupied by the process second process. So in this case, no process will not complete their execution. In that case, the deadlock will occur. This is the deadlock definition. And next one is here. This is the introduction of deadlock. Here, deadlock is an important concept in the operating system where it happens when two or more processes executing at a time. The resources shared by these processes. So one process is waiting for the another resource, already holding one resource, and that another resource is held by the another process. In this case, no process will complete their execution. At that time, the deadlock will occur. So in the deadlock, these are the terms are important terms. We need to know what is meant by process. Process is nothing but a program under the execution for completing a particular task. That is nothing but a process. Next one is resource. Resource is nothing but resource is any type of entity required by the process to complete their execution. These resources are allocated to the processes that is done by the operating system. If the resources are there available means then only the process will complete their execution and its tasks. And the next one is definition. The deadlock is occurs when in multi-programming environment at that time the multiple processes are executing simultaneously. In this case, the resources are held by the processes. The another processes are requesting that resources held by another process. In this case, the no process will proceed their execution. So in this case, the deadlock will occur. The each process holds the resources and waits to identify for another resource held by the another process in the group. This is the real-time example. Here, the real-world analogy for deadlock is using the traffic grid scenario. In this case, the junction having there are 4 cars passing through the way. In this case, the image shows that no car will pass through. They are stuck and waiting to other cars to pass the way. So in this case, no car will go the way, and in this case, deadlock will occur. This is the real-time example for deadlock and the necessary conditions to occur a deadlock. The necessary conditions for occurring a deadlock, there are 4 necessary conditions. First one is mutual exclusion and hold and wait. and third one no preemption, and fourth one circular wait. The mutual exclusion. First we'll talk about the deadlock with a diagrammatic representation. We can take one example that depicts the deadlock here. First, the resource 1, and resource 2, and here process 1, process 2 are there. In this case, that first resource is allocated to the process 1, allocated to process 1, allocated to the process 1, and this process 1 requesting the resources of resource 2, requesting the resources 2, and the resources 2 are allocated to resource 2 is allocated to the process 2, allocated to process 2, and this process 2 requesting the resources 1, requesting the resources 1. In this case, if the process 1 completes their execution, means it is also it requires the resource 2 as well. It already holds the resource 1, and to complete their execution, the resource 2 also it required to complete their execution. Here the process 2 is also having the resource 2, and this process completes their execution, means it requires the resource 1 also. So in this case, no process will complete their execution, so the deadlock will occur. Next, we'll go to the necessary conditions. Necessary conditions to occur a deadlock. Here there are 4 conditions. First one is mutual exclusion, and second one hold and wait, third one no preemption, and fourth one circular wait. A mutual exclusion means at that particular time only one process will hold the resource. That resource is not shareable. If shareable means the resources shareable to 2 processes, means the deadlock will not occur. So the resource taken by this is non-shareable resources, like a printer. Example, printer is one of the resource. It will, while one process is allocated to that one process is using that one resource, printer, then no other processes are using that one. At that time only one process complete their execution. So one process complete the printing part, then only it will goes to the, it is allocated to the another process. And next one is hold and wait. The process holding the resources can be voluntarily, it release the resources. So we cannot forcefully releasing that resources and allocated to another process. So here the processes are having already one resource that is held by the process, and again it is requesting to the another process hold by the another process, requesting the resource by holding by the another process. So in this case also deadlock will occur. Then third one is no preemption. Preemption means when while executing the 2 processes, when high priority process will come, the low priority process will stop their execution, and it is waiting in the, it is stopped and waiting in the waiting queue, and then the high priority process will complete their execution. In this case also the deadlock will occur. And the fourth one is circular wait. The name itself is indicates that it will form a circular chain. In this set of processes are there. First process A, that will wait for the hold the resource 1 and requesting for the another resource hold by the process B. That process B holds the resource 2 and requesting the requesting the resource 3, that resource 3 is held by the process 3. In this case, so it will form a chain. So the last process is requesting the resource held by the first process. So in this case, no process will complete their execution. So this condition also forms a deadlock. And next, we go into these are the necessary conditions. And next, we are going to explain the handling method. First one is mutual exclusion. Mutual exclusion means here the resources cannot be shared between multiple processes. That resource is non-shareable. So the resource is either assigned to a single process or is available for another process to request. So the second process is waiting for that resources until the first process release the resources. So in this case, deadlock will occur. And these are the example. We can take the printer as an example. It is a non-shareable resource. So only one process can use at a time. So the first process will give the printing. After completing that printing part only, then it will allocate it to the next process, second process. Meanwhile, that second process will wait until the first process complete their execution. Next, second condition is hold and wait. Here the condition occurs when holding the one or more resources by one process at a time and waiting for another resources that are acquired by another processes. So in this case, the process waits until the first process release the resources, then only it will allocate it to the second process. So in this case also, the processes are waiting in the waiting list. So then the deadlock will occurs. And here the example is the process holding a lock on the database table while waiting for a file to be available. This is the hold and wait concept. And next condition is no preemption. The preemption means when high priority process will come, then the low priority process will stops their execution, and that resources are allocated to that high priority process. After completion of the high priority process, then only it will allocate that resources to the first process. So that resources is voluntarily the process will release, and that is after completion of their execution. For example, the process using a printer must finish its printing task before it release the printer for another process. This is the no preemption. And next one is circular wait. Circular wait occurs when group of processes form a circular chain. Each process is waiting for a resource held by the next process in the chain. In this case, for example, process A holds the resource 1 and waits for the resource 2 that held by the process B. That process B holds the resource 2 and waits for the resource 3 that is held by the process C. So process C holds the resource 3 and waits for the resource 1 held by the process A. So this creates a cycle or chain. So in this case, no process will complete their execution. Due to this, the deadlock will occur. These are all are about the conditions to occur a deadlock. And next one, we're going to discuss about the deadlock handling methods. Deadlock handling methods are 4 types. First one is deadlock prevention, deadlock avoidance, deadlock detection and recovery, and next one is deadlock ignorance. These are the four methods used to handle the deadlocks in operating system. First, we discuss about the deadlock prevention. To prevent the deadlock, first the 4 necessary conditions are there: mutual exclusion, hold and wait, no preemption and circular wait. These 4 conditions occurs only means then only the deadlock will occur. We need to eliminate any one of the condition means then there is no deadlock will occur. So while prevention is better than the cure. Like while after occurring the deadlock, we can handling is difficult. So before occurrence also we can use eliminate this any one of the necessary conditions and we can prevent the deadlock. So first one is deadlock prevention method. In this, retain the ways request can be made. First one is mutual exclusion. This is not required for shareable resource, must hold for a shareable, non-shareable resources. When shareable resources are there, at the same time multiple processes can access the that resources at the same time. So then the deadlocks will not occur. And eliminate the hold and wait condition. Must guarantee that whenever a process requests a resource, it does not hold by the another process. In this case, another resources, if it required, then it first release the resource held by the process after completion of their execution. In this case also, it will, if we eliminate this condition, then deadlock will not occur. Next, third one is no preemption. If the process that holds some resources and requests another resource that can be immediately allocated to it, then all resources currently being held be released. If already one process holding the resource and another process till wait until the first process completes their execution and release that resource, then only it will allocate it to the next process. So here, whenever high priority processes will come, the low priority processes will wait until the high priority process complete their execution, then only the low priority processes will execute. And next one, circular wait. Circular wait also, it imposes the total ordering of all resources types and require that each process requests resources in an increasing order of enumeration. So in circular wait, first one process holding the resource and that resource is requested by another process, and second process is holding the resource that is requested by the third process holding a resource and request the first process resource. In this case, it will form a chain. So that circular chain, in this case, no process will complete their execution, due to that deadlock will occur. So eliminating the circular wait also, we can prevent the occurring of deadlock. These are the 4 necessary conditions. So any one condition we can eliminate means we can prevent the occurrence of the deadlock. This is the first method. And come to next method, deadlock avoidance. Deadlock avoidance is also when deadlock is occurred, then we can avoid that occurrence of deadlock. Means we can use two algorithms. That is, first one is Banker's algorithm and second one is the resource allocation graph. These two are using to avoid the occurrence of deadlock. First one is, it is a strategy basic. Banker's algorithm is one of the most used algorithm that used to avoid the occurrence of deadlock. The strategy used in the resource allocation system, these algorithms simultaneous the resource allocation for each process and ensures that the system remains in a safe state. Safe state means here the requested resources is available for the process. If whenever the process is requesting a resource, then that resource will be immediately allocated to that process. In this case, the safe state, there is no deadlock will occur. Yes, here we are discussing about the Banker's algorithm and resource allocation graph. This is well known deadlock avoidance algorithm, which one is used to assign the resources to the processes so that the resource allocation is made with the resource allocation graph. These two methods are used to avoid the deadlock to occurrence. In this resource allocation graph is used to representation of the processes and resources in the system. In this, we can use the wait for graph also. In this, that wait for graph represents how many processes are waiting for the particular resource, so that the operating system will allocate the resources to the particular process based upon the resource based upon the request from the resource processes, so that available, if the requested resources is available, then it immediately allocate to the requesting process. Otherwise, the requested process must be wait until the requested resource is available. So these two methods are used to avoid the occurrence of deadlock. And next, another method is deadlock detection and recovery. This is also one of the method we use to detect the deadlock, the occurrence of the deadlock, and we can recover from that deadlock. This approach let us the process fall in a deadlock, then periodically check whether the deadlock will occur in a system or not. So we can identify that there is a deadlock in the system, then it used for the recovery methods, and we come back to the that situation and complete their execution. If it is occurs, then it applies some recovery methods to the system to get rid of the deadlock. So in this, deadlock detection is very much important. In prior, we can detect that deadlock is occurring, then we can recover from that, we can use the recovery methods. And the main task of the operating system is to detecting the deadlocks. Then the OS can detect the deadlocks with the help of the resource allocation graph. Here, next one is deadlock ignorance. This is also one of the method. This method is also called as a ostrich method. In this method, the deadlock ignorance is the most widely used approach among all the mechanisms, because in this method is used by the operating system mainly for end user uses. Whenever the deadlock will occur, it simply ignores and restart the system. Then it simply ignores the deadlock and restart the system and work. There is no deadlock in the system. So this approach is best suitable for a end user single end user system, where users use the system only browsing all the normal stuff. So this is the ignorance. With whenever the deadlock will occurs, the simply it assumes that there is no deadlock in the system and ignores that deadlock, simply restart the system and works normally. These are the four methods and used in the deadlock handling methods. These are the main terms to know about, we know about the in operating system. So the first one is concurrency and second one is contention. The modern operating system allows multiple processes to execute simultaneously and leading to resource sharing scenarios. And contention means while it occurs when multiple processes requesting the same resource, creating potential for conflict. These are the terms, and we can see the video of the to explain about this concept, deadlock concept. With this video, we can easily understood. So in this video, two friends are went to restaurant and they can order the food. In this table, they order same type of food. In this table, we have only two spoons. First one is spoon and second one is fork. Only two spoons are there. They are eating means they are using the two spoons at a time. So only two spoons are there. If one spoon is used by the one friend and another spoon is used by the another person, then they won't eat that meals. So in this case, both are hungry and they are wait for that resources like these spoons. Whenever they have two spoons only, they can complete their ordered food, they can eat. In this case, this is we assume as these spoons are resources and these two friends are processes. The both are the waiting In this situation, no one will complete the meal, or they are not having this meal because of the resources are not available. So here the deadlock will occur. This is the diagram. It depicts the how deadlock will occurs. The process A is the process A is requesting the resource to and already allocated the resources to the process A, and this resource 2 is allocated to process B, and the process B requesting the resource 1 that is held by the process A. In this case, the both processes they are in waiting state, so they are unable to complete their execution. So if one process these resources whenever relieved, then only it is allocated to the process A. So here, like we previously tell that there are two friends waiting for the only resources that is held by the another process. Like process A is holding the resource and requesting for resource 2. Here it is in waiting state, that process A. And again process B also holding the resource 2 and requesting for the resource 1. In this case also this resource 1 is allocated to process A. After the releasing only it will allocated to the process B. This is also in waiting state. In this case both processes will wait for infinitely, so the deadlock will occur in the system. So we can say for this occurrence of a deadlock, we have 4 methods, necessary conditions. That conditions is, first one is mutual exclusion, and second one is no preemption, and third one is hold and wait, and fourth one is circular wait. These are the necessary conditions to occur a deadlock. If the 4 conditions occurs only, then only the deadlock will occur. If any one of these conditions not occurred, means the deadlock will not occur in the system. This is our topic. Next, we discuss about that conditions. Mutual exclusion. Mutual exclusion means that resources are shareable or non-shareable. If the resources are shareable means if resources are shareable means that resources are allocated to both processes at a time, so they can easily execute and they can complete their process. So here if it is non-shareable resources only, then only the mutual exclusion condition will occur. The resources are which is presence or waiting must be mutual exclusion, that is non-shareable. If the resource is non-shareable only, then only the deadlock will occur. If it is shareable means here the resources is allocated to process A and also allocated to process B. So if process B are already resource 2 and resource 1 is there, means it complete their execution and release the resource 2. In this case also these both resources is available means the process A also completes their execution. So there is no deadlock will occur in the system. And the next one, no preemption. Here no preemption. Preemption means we cannot forcefully taking the resources from the process. The process will voluntarily release the resource by itself only after completion of their execution. After completion of their execution. Here first one is the process B. Process A is requesting the resource 2 and that is allocated to the process B. So the resources are not shareable. Here it should be forced to stop. If we stop means this resources is allocated to process A, so that the process A will complete their execution. Next one is hold and wait. Each process must hold a resource and it have one resource and also requesting for the more resources that are held by the another processes. Here we can show that resource 1 is holding the process A and waits for the resource 2, and process B holding the resource 2 and waits for the resource 1. Here it is holding one resource and process A is also holding one resource and waiting for the second resource to complete their execution. Here no process will complete their execution, so due to that deadlock will occur. Next one is circular wait. Circular wait in the sense, first, so here we can take the three processes, that is process A, process B and process C, and here the resources are resource 1, resource 2 and resource 3. This resource 1 is allocated to process A, resource 2 is allocated to process B, resource 3 is allocated to process C. So process C already resources allocated means it will complete their execution, but that completion of their execution, it requires the resource 1 that is held by the process A. In this case it will form a chain, so the no process will complete their execution. In this case it will form a chain, so one process is waiting for the another resource, so in this case also the deadlock will occur. These are the four necessary conditions.